So this problem just wants us to solve. It doesn't tell us how we have to solve it or really, any way that we need to do that. So what I suggest is that we know we are looking for the zeros. That's how we're going to solve this equation. Now, when in doubt, what's the first thing you always do when you're looking for zeros? Well, you need to find the possible rational zeros. And in order to do that, you have to take the constant coefficient, which is the 13, your leading coefficient, which is a 1, and then we're going to divide. So I'm going to get plus or minus 1 and plus or minus 13. Well, that's great. So that gives me a place to start, right? I know that maybe 1, maybe negative 1, maybe 13, maybe negative 13 is a possible solution. Well, as I said, you always want to start with 1. So let's start with 1. So we're going to use synthetic division because it's x to the 4th. I need to my leading coefficient, so I've got a 1, minus 6, 22, minus 30, and 13. So I'm going to go ahead and bring the 1 down. I get 1, I get minus 5. Multiply those, I get minus 5. And then I get 17. Multiply those, I still get 17. I add those together, I get minus 13. I multiply, I get minus 13. And look at that. 1 works right off the bat. Now that I have that, let's just look at what that looks like. So this would be like saying x minus 1 times, and this would be x to the 3rd minus 5x squared plus 17x minus 13 equals 0. So that's basically what we've done. We've already taken out one factor. So if what I'm doing is I need to just look at this second part here. So I'm looking at this now. And if I were looking at that, you notice it still has the 13 hanging out, which means that my factors are still 1 and 13. I need to get it down to an x squared if possible, so that I can either use the quadratic equation or I can do regular factoring. So what I recommend is, again, let's try synthetic division one more time and see what happens. Now, my only factors I have are 1 and 13. 13 doesn't really appeal to me because I don't have very big numbers. So I'm going to just try 1. Let's just see what happens. So I do a 1. My coefficients now are under this blue line, so I've got 1, minus 5, 17, minus 13. So I'm going to bring the 1 down. 1 times 1 is 1. I get minus 4. Minus 4 times 1 is minus 4. 17 minus 4 is 13. 13 times 1 is 13. Oh, and check it out. Today was my lucky day. We got a 0. So that means that in this case, 1 is what we call a double root. It's used twice. So now what it looks like is I have the x minus 1 from before. I have the x minus 1 we just did. And now I'm left with x squared minus 4x plus 13. So we've already solved the first two, but I'm going to go ahead. This is x equals 1, and this is x equals 1. Now here's the kicker. I've got x squared minus 4x plus 13. Are there any factors of 13 that add up to 4? And the answer is no. So what that means? That means we have to use the quadratic formula again. I know, it's killing you, but it's going to be okay. So let's go ahead and start up here in the second column. So I've got x squared minus 4x plus 13. So this is in A, B, C order. So I want to actually go ahead and insert those into the quadratic. So I've got x equals the opposite of b. So the opposite of minus 4 is 4 plus or minus b squared. So minus 4 squared is 16 minus 4 times a times c. So 4 times 1 times 13. So it's 13 times 4. Make sure I'm doing the right thing. So that's going to be 52. And that's going to be over 2a. But a is 1. So now when I simplify this, I get 4 plus or minus the square root of, and I'm going to get a minus 36 over 2. Remember we talked about complex numbers, so I is the same thing as the square root of negative 1. 36 is also perfect, so this is going to be 6i. And this is all going to be over 2. Now each term has a 2 in common. So I can take and divide by 2, so this will give me a 2, and this will give me a 3. So I get 2 plus or minus 3i, don't forget the I, over 2. So there's two of my solutions. Now remember, we also said that 1 is a solution. We used it twice, but we just write it down one time as a solution.